I don't know. If there's anything in Discord, can someone just raise their hand and tell me? Will be the easiest way. I don't like not having Discord for demo lectures. So today's all about demoing WebSockets, and just show you a lot of the more practical side of what we saw the last two lectures. It's very thinned out here. It's the parking lot too. It seems pretty widespread. Like, I understand for Thanksgiving taking that Monday off, and I just cancel those lectures anyway because very few people show up. But spring break, like, you get a whole week. You want to extend it by one day?
A lot of people work hard unless you have a break.
Oh, that'll do it. That'll do it. Yeah, okay. That could be too. Sure. Yeah, once one or two classes cancel, you're going to skip the rest. All right, but let's get started. Since you did come today, let's do some good stuff here and learn some content. So first I want to talk about how to test. I pulled up the website so I can get the slides here. Just as a quick review, all the way in section 3 already. Quick review of the handshake. We have this one slide that's really everything you need to know about the handshake. If I can get there, this one. So we're going to get a request for an upgrade to WebSockets, and that's going to contain this WebSocket key. And we're going to take that key, append this globally unique ID to it, which I'm going to paste over here. Oh, come on. Just understand that I want everything to be that text. We're going to append this globally unique ID to it, compute the SHA-1 hash of that, and then base 64 encode that, and then that's our accept. So to test this, what I strongly recommend, go to any site that uses WebSockets. Twitch happens to use WebSockets. And we'll watch some Elden Ring. And go to the console. Oh my goodness, what is happening here? You think I want to see the CSS? It's hard to do this so zoomed in. I got to zoom out a little bit because the console just wants to take up so much room. I just want to be able to not look at this ever. And it's frustrating that I can't just get rid of that. At least, probably one of these buttons does it and I'm just dumb. But this is the timeline. It's showing you the timing of all your requests. So the very first request over here to get the HTML happened pretty quick. Then you can see which requests are happening at that time. Yeah, there's definitely, there gotta be a way, but I don't know. I think I'm just dumb. So I'm gonna refresh, look at all of my requests. The video here actually works off of, I forgot the name, HLS, I believe, HTTP live streaming, I believe. And these requests are for all the data for the video. So the video isn't actually a stream. It's actually a whole bunch of HTTP requests to get the next chunk of the video. Just happens to be how Twitch works. It's not actually live. It is delayed by like 10 seconds or so. Twitch gets the stream as an RMTP stream, processes it, changes it into an HLS files, and then serves the HLS files over to you, which are chunks of video in different qualities. So each video is stored in multiple qualities, and then depending on the strength of your connection, the speed of your connection, you'll get whatever quality is acceptable for that, or if you manually change the quality. So it's actually not strictly streaming. YouTube works the same way because you don't need streaming. Like when it's Zoom, you need streaming because you need the lowest latency possible. But when you don't need the lowest latency possible, there's actually other things we can do. Where we do want the lowest latency possible, or maybe not the lowest latency possible, but is in the chat. So chat actually does work off WebSockets because you do want to get those messages pretty quick. And for other reasons, there's no processing that needs to be done. It's just text. The video, there's a lot of processing. you're not getting the same video that the streamer uploaded to Twitch. You're getting the HLS version instead of the RMTP version. So we can look at one of these, and for testing, we want to talk about testing the WebSocket handshake. I strongly recommend doing this. Go to any site that uses WebSockets. Go to the headers, the pertinent headers. I'm naming this like it's a variable. Just seriously, why? That's what I'm trying to do. I'm trying to find the shortcut of paste and match style. And I'm not getting there. Edit, paste and match. Control Shift Command V. Control Shift Command V. And of course it doesn't work. Am I hitting the wrong button? Oh, there we go. Okay, I got the shortcut. All right, so that's what I'm expecting when, if I scroll down to the request headers, when this is the key. So when this is the key, this is the accept that I'm expecting. And what I want to do is compute this. I'm going to compute it manually, but of course you would do this with code. You can refresh your page over here and get as many test cases as you want. There's one situation where I strongly recommend test cases. Test cases are one of those things where like we force you to do it in 116 to show you what they are. And some of those questions you might think are a little easy, that you didn't really need the test cases. But you learn the concept in 116. And then it's up to you after 116 to decide when should I write test cases and when when can I kind of not bother. Because there's code, I'll admit, there's code that I write where I don't write test cases. This is one situation where I'm writing test cases. Every time I write my solution, and I write my solutions to the homeworks in different languages all the time. Whenever I write my solutions, this is one situation where I'm writing my test cases. 100%, I'm always writing my test cases for this. It just speeds the development process up so much. I can click one button and see if I got it right. And I don't want to have to run my server, go to the browser, open the browser console, and check to see if that 101 response came in the way I expect. And even if it does, like this will say, connection, I don't even know what it says when you have the wrong accept, but it'll say some kind of error, and you won't get the 101 response. And that's hard to debug. First of all, that takes a long time. I guess that's the main reason. It takes a long time to do that, and I'm not bothering. And it's not 100%. How do you know if it worked or not? You would have to actually send messages in your chat and make sure the messages got there to the other side. So this is one case where write your test case, run your tests, and run them until your accept is equal to this accept. One click of a button, boop, or one, if you're using command line, one Python, whatever, run my test. And you can check it to see if you have the exact right string. Strongly recommend it. Also, parsing your WebSocket frames. Strongly recommend to write test cases for that. Take a frame, and we're going to show that. I'm going to show that too. Get a frame, get the bytes of the frame, put that in your test case. You know exactly what that message is supposed to be. Do it by hand if you're unsure, and then write your parsing to make sure you extract the correct values out of that. Extremely faster than running your server every time, sending a chat message, seeing that you didn't get the chat message back, and then trying to debug what the hell went wrong, and you got 100 print statements in your server, and you're trying to figure out what's going on with that. Don't put yourself through that. Grab one WebSocket frame, put that as your test case, set all the expected values, put all your asserts in there, and use your test cases. It'll speed up your WebSocket debugging significantly because there are a lot of little things that can go wrong with WebSockets, with computing this accept and parsing the frames. One bit level manipulation that didn't go the way you expect it to, and everything blows up. So let's do this by hand. Of course, you'll be doing it in the code. We can get rid of our test case generator here. And I want to show you that the handshake is just these two commands. So first, SHA-1 calculator. I'm going to do something first that isn't going to work. So when this doesn't work, don't be like, whoa, he doesn't know how to do this. This isn't going to work. So I'm going to compute. Now I'm going to feel like an ass if it does work. If I can get the whole damn thing. With all these special characters, you can't just select it as one word. I'm going to compute the hash of this. Oops, I already messed up. So my key, my GUID, I'm almost writing this as pseudocode since I'm declaring these as variables. My 2 hash equals my key. Appended to this global unique ID. So this is appended to the end of that key. Oh, thank you. That would have been a mess. Thank you so much for that. I'm going to hash this. And I recommend going through this process as well. Going through each step manually like this, so you can get all your intermediate values too, so you can narrow down your debugging. Was it my base 64, my SHA-1 hashing, or my appending, or did I miss a 1? Did I skip a character? You can know exactly where your code is going wrong. So I get the hash of that. I'm actually going to close that hash calculator. And then I'm going to base 64. Actually, I did kind of want to keep that. Get a base 64 calculator, just any base 64 calculator. Take this hash. I want to encode, not decode. Does it go the other way? You know what? Screw this one. You lost my business. And we're going to get base 64 encode that hash, and we're going to get something that's not our accept. So this didn't work. This is one of the pitfalls that you might run into. I took the SHA-1 hash of the concatenation, and then I base 64 encoded the hash, and it didn't work. And I expected it not to work. So the problem here is that my base 64 encoding was taking UTF strings and treating this hash as the character B, the number, the character 3, the character F, etc. When, in fact, this hash, if you look at it, you can tell that that's hex data. So this is a hex. These are hex values in the hash, and I'm treating that as a UTF-8 string. So we want to find a base 64 encoder that's going to take hex as an input. So in your code, when you use your base 64 encoder, make sure it's not expecting UTF-8. Make sure it's expecting the bytes of data. Make sure it's expecting bytes. So I'm going to paste my convert base 64 to hex. I don't want to do that. Hex 2, I shouldn't have used my clipboard for that. Hex, convert, and that should be looking pretty familiar. I don't have monospace font right now, so it won't line up exactly, but we should get that same exact string. So concatenate the GUID SHA-1 hash, that's going to return bytes, and then base 64 encode the bytes. Don't treat the bytes as ASCII characters. Make sure you're encoding the bytes and staying in the world of bytes. Don't convert this away from bytes. And usually your base 64 and your hash is going to, your hashing function is going to take bytes as an input. So after this concatenation, you'll have to encode this as a byte string, hash it, That's going to return another byte string or an array of bytes and then hash that. Let's get rid of this wrong one. We don't want that. That's the base 64 encoded UTF-8 string, interpreting each of these characters as UTF-8. We don't want that. We want to interpret these as bytes. And actually, let me get that back. And we can see that this should be, let's see if it is. It should be exactly twice as long, or at least roughly twice as long as this. No, not quite. Because each two characters in the bytes, like B3 is a single byte, whereas if it's ASCII, then B is a byte and 3 is a byte. So there's twice as many bytes in this as a string than this as hex. So we expect that hash to be about twice as long. It wasn't quite twice as long. I'm sure there's a good reason for that I don't know off the top of my head. But we expect that to be a longer base 64 encoding. And just a reminder, base 64 is going to take any arbitrary bytes and convert them into an ASCII string. So it can be represented as ASCII text. Any questions on that? I can't read chat. I feel so lost. Why is there a request fail? So when you, I closed my Twitch. But when the browser requests to open the WebSocket connection, it's going to send the, I did close it. So it's going to send the request. It's going to say, here's a request to upgrade to WebSockets, and here's my key. Here's my randomly generated key. And then in the response that comes back, it's expecting a 101 response code. It's expecting the headers for upgrade to WebSockets, the two headers to upgrade to WebSockets, and the correct accept that we just computed here. If any of that's missing, the browser's going to say, no go, this is not a good connection because you don't speak WebSockets. If you don't speak this protocol, I'm not establishing a connection with you. I'm not leaving this TCP connection open and treating it as a WebSocket connection, just not doing it. It's the way the protocol works to prevent accidental connections. Like you have to compute this very exact thing, and the browser's looking for that very exact string. If it doesn't see this, it's a no-go. It says no connection. I don't remember the exact error that it comes up with, but it will show you some error in the console. I believe in the network tab, it'll show you. I don't know because I always do testing for this. I write some unit tests and test that way. So I don't remember what it does when the connection fails. I guess we can try it maybe today. But anyway, but there will be some error if you don't have the correct accept. Yep. You know what? I just got to open it up again. Oh, we're cooking now. Is it not open chat until after the ad? No, connect to the chat. Yeah, what the hell? That's weird. So the key is going to be in the request headers. So when the browser is making the request and sending that to your server, there's going to be 3 headers that have to exist. One header is going to be upgrade with a value WebSocket. That's always going to be there. The other is going to be connection upgrade. Those 2 headers say, I'm requesting to upgrade to WebSockets. And then the third is going to be the sec WebSocket key, and that's where you're getting your key from. So you're calling your header parser that you all hopefully wrote in homework 1, and grabbing the key. You can just assume the other 2 are there. It's not going to hurt you. You're getting a request for the path of your WebSockets. This has a whole different URL, a subdomain for their WebSockets, it looks like. But when you get a request for your path of your WebSockets, then you know to look for that key. And then in your response, you're going to have, at a minimum, the connection upgrade and upgrade WebSockets identical to what the browser sent to you, and this sec WebSocket accept, which is going to be the accept that you computed. If those three headers are not there, or the accept is not the right value, or you like capitalize the U in upgrade, I think it's that finicky that you need these exact, then the client's going to reject the connection. But the short answer to your question is it's in the headers. Grab it from this header from the request for the upgrade. Yep. Yeah, the browser's going to generate a random key and send it to you in the header of the request. All right, everyone good on this? Okay. Let's get this out of the way, and then we can just do more demos. I'm going to try to debug my damn thing. Kinda, but I don't know. I don't want to do that. What? I mean, this is open until 11, so you got time. Just write down your answer. Oh, I know why this isn't working. Fuck. It's because I deleted the app this morning. My phone kept whining that it was, low storage. And it's like, delete these apps and you'll free up some storage. I'm like, yeah, I don't use those. No, it's one that I use every effing day. Thanks a lot, Android. Yeah, secure W2. I deleted that this morning. Guess it's my fault. Okay, and once you have a connection, you can go to messages and see all the messages. This also helps with debugging, just since I'm right there. But now let's see another side of this. Let's get this out of the way. Let's get this on screen. Of course, it's going to be a pain. Let's go over here. Oops. Let's go over here. Let's go over here. Let's go over here. Okay, so my server's running. I'm going to not show code today. But my server's running. And I want to go to my browser and go to localhost 8000. Should work. But I want to go to my page with WebSockets. For your homework, you'll add this to your home page, but I did it as something separate just to be able to test easier. I'm going to go to my other side, and we can see, I don't think I'm printing out everything here, but just to show, it should be down here. I got a GET request for WebSockets. And we should see those three headers in here. WebSocket version, the key. The other two are in there. I don't feel like searching through them. They'll definitely be there. Oh, right here. Connection upgrade and then upgrade WebSocket. They'll be in there. They have to be. And the U is capitalized. I should have been paying closer attention to that. In Twitch, they're probably not using HTTP 1.1. In later versions, all the headers are lowercase. I don't know why, but I don't know why they would change something like that. But they did. And we have to live with that. Hey, I have internet again. Thanos. And I missed a good meme. Hit the gear at the top right and then uncheck show overview. Oh my God, I'm doing that. Thank you, Nicholas. You don't need the app. Yeah, I don't know how to connect to it without the app, though. I want to connect to UB Secure. I used to be able to connect on my phone. Then one day it just stopped working. I'm sure UBIT updated something that they decided our lives weren't difficult enough. So they had to update it. All right, so I'm going to send something. Well, let's do a proof of concept here. I'm going to send hi, and I'll see it in the other browser. Hello. We'll see it in the other browser. So we have live chat. Those would be immediate updates. So my WebSockets are working. That's objectives 1 and 2 right there. So let's take a look at what happened in our browser when we sent those things. And we want to parse these WebSocket frames apart. So I'm printing out, and I recommend you do this same thing. It takes a little bit to get this format if you want this format. But I want to print these out the same way that we're used to seeing them in, let me resize things so we can do this. The same way we're used to seeing them in the protocol documentation. Doing it like this might be sensible. And then I'm parsing it and then printing out, oh, I wish I had a new line there, but printing out what I expect, what I parsed from these values. Let's get things all on the screen. So the payload length I extracted as 47. This is a JSON string, message type, chat message, and the comment of hello is what was received. Then I ended up sending, I don't show the frames that I'm sending, but I'm sending the frame message type chat message, adding the username, which I'm randomly generating. You can just, I gave you the line of code in the homework handout if you want to generate usernames the same way I'm doing. Anyway, you can generate a random username. We'll get legit usernames in homework 4 when we do authentication. And then the comment of that username. The big thing here is that the username is added to the JSON string. So you do, the whole reason I'm doing that is so you have to recompute the payload length. You have to actually compute those, no cheese in that one. And you also have to escape HTML in the comment. So if there's any HTML to be escaped, that's also changing the payload length. So you do have to recompute your payload length. Very important that you actually get practice doing that. So let's take a look at this and see what we have here. These are all the bytes, or the bits. You can print things out. I think the 3rd week of this, I'll show demos of how to print things out in this the screen. We have those 3 examples lectures. For today, not so much. But let's count these bytes of payload. I got 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 40, 41, 42, 43, 44, 45, 46, 47 bytes takes us up to here. So this is my payload length. Assuming that I already extracted that and I know it's 47, I know that this is my masked payload right here, which is going to be all of my payload data down here. Now, of course, you won't reverse it like that, but I just want to show what we eventually expect. So the first byte is going to be my fin bit, my reserve bits, and my opcode. My first 4 bits, 1, 0, 0, 0, fin is 1, reserve 0, 0, 0, which we can assume in this class. My opcode is 0, 0, 0, 1, which is going to be the opcode for text data. I know this frame contains textual data. Oh, I'll move this, but I can't. My mask bit is 1. So I know that this data is masked. And then I have 7 bits of payload. This payload is not all 1s, then a 0, or all 1s. So I know it's not 126 or 127. So I know this is my payload length. And if we add this up, I'll try to, you know what, let me just pull up my calculator. I was going to say I'll try to do this in my head, but it's 1 plus 2 plus 4 plus 8. There's no 16, and then plus 32. And we should get our 47. That 47 is exactly the payload length represented by those 7 bits. If those 7 bits are exactly 126 or 127, then I know I have more work to do with the payload, and that'll be the next thing we'll see. Then the next 4 bytes are the mask. So if I go back to my, that's the wrong one. That's in the video now. Text edit. Take my mask. I'll just grab the first 5 just to really drive the point home. First 5 bytes of data. And we XOR these. Hopefully I can do this fast-ish. 1, 1, 1, 0, 1, 1. This is the hot content you all came for. 0, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1. And then the last byte, the 5th byte, is going to be XORed with the first byte again. So we take the first byte of the key and wrap around and then start over again, taking those 4 bytes of the key, the masking key, over again. 0, 0, 1, 1. And these are my first 5 bytes of my message. And if I go to binary to ASCII, should get me there. I'm getting the first 4 bytes of my message. So after parsing this, after decoding everything, I get this message type stuff. My first 5 bytes of that were actually the first 5 bytes. So we XOR to demask it, and then interpret those bytes as our string. Won't always be ASCII, it can contain UTF-8, but you get the idea of unmask that, and then that's the actual data of your payload. So you take the mask and go through every byte. I recommend iterating through each byte, find the byte of the mask that you need to decode with, instead of trying to do it 4 at a time. Don't try to tackle this 4 at a time. It's tough to do that. I see that trap. Students run into that trap fairly often. And if I close one of these tabs, did it not? Oh, am I not printing it in the right spot? Well, I get my disconnect. We'll have to read it like this without the binary. Apparently, I only do the binary after everything's decoded, and disconnect I'm handling before that. But my first byte is 8, 8. So if we look at our WebSocket frame, 8 is 1, 0, 0, 0, and then another 8, 1, 0, 0, 0. My opcode is 1, 0, 0, 0. So I know my opcode is a disconnect opcode, and this is a disconnect request. And if I try to parse this the way I parse the other messages, I might get myself into some trouble. This, in my browser, I've been getting this where the mask bit is 1, the payload length is 2. I have a 4-byte mask. Oh, I went too far. And then 2 bytes of data, which are just kind of, I don't even know what they are, but they're not text. It's not going to be valid UTF-8. So if I threw this into a UTF-8, expecting UTF-8 messages, expecting text messages, I'm going to get a decoding error when I try to decode those 2 bytes as UTF-8. Or is it? This actually looks like it might be. I don't even know what it is. But anyway, when you get the disconnect code, just parse the opcode and then stop right there. Sever the connection, it's over. So let's do another test here. I have 10. I like to do this just so I can keep count of things when I'm sending large messages. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Let's go with 200. Message worked fine. And now I'm going to get much more data in my payload. I have a payload length of 242. So when we have a payload length more than 125, I'm going to expect the payload length to be all ones, then a 0. So this payload length is now 126. My payload length is greater than that, of course, but 126 says the payload length can't fit in 7 bits, so use the next 2 bytes as the payload length. I I don't need that whole first byte, but I do need one extra bit here. And this in decimal is going to be my payload length of 242. So it's the same idea, except my payload length is going to be in those 2 bytes after the 7-bit payload length. And if we keep going with that, 100, 200, 3, 4, 5, 6, 7, 8, 9, 10, that's 1,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100,000. Let's send 100,000, and we'll get a pretty big message. It's not the cleanest way to test that, but it works, by the way. And we'll get a pretty big message here. Hopefully I didn't overflow my console. I think I did. Yeah, I did. It was a little too big. A little bit too big. We went a little overboard there. The point is that worked, though, as it should work. You can see my tab down here. That should work even if you have 127 as your 7-bit payload length. And it's easy enough to test. We can just use your text box. We don't have to use anything crazy. So if you want to test yours, do the same thing I just did, and you can get some testing done. Okay, so here we did get this, but I'm not using 127. I didn't quite get that far because I'm overflowing my thing. But now these 2 bytes are going to be the payload length. So we got 1, 2, 4, 8, 16, 32, 64, 128, 256. I shouldn't have done this. 512, 1024, 2048, 4096, thank you, and like 8,000 something. So, what is it? 8192, thank you. So we expect the payload to be greater than 8192, and the way I was pasting it, I think it was exactly 10,000, right? The way I was doing it. Except for the overhead with the JSON. I skipped over it. Yeah, 42 bytes of overhead with the JSON and a 10,000 byte image. So we can extract the payload length with those bytes. This one gets a bit trickier in the code. I'm not scrolling back up. But this one gets a bit trickier in the code because you have 2 bytes of data that you need to combine to form a single integer. So keep that in mind. You're expected to find a solution with that. If not, I probably will demo that in the 3rd week of this, but I wouldn't wait that long to be able to handle this. This is Objective 3 stuff. You don't want to be waiting that long. Of course, I say that knowing a lot of you are still working on homework 2 at the last second. So, but I'll show some demos. I'll likely show some demos. I might not, too, so if I have other things I want to demo during that week. So that's going to be larger messages. And I think those are the big ones I wanted to demo. Oh, of course, the other one. I have to restart this server because it's going to break the way I have this set up. Actually, it might not, but I don't remember if I fixed that bug or not. So let me restart this. Catch up on chat while the port frees up. Logging in with your UBET password worked. Shit, I should have tried that. I think I did a while ago, but I might not have done it right. For the chat, do you need to support UTF-8 characters? To be honest, it'd be hard not to. Like you'd have to have extra code to say if some of these characters are UTF-8, deny them. So yeah, you should. I don't know if we'll explicitly test that because there's no extra work. It's not like the payload length. Like we're working in bytes already. It's not like the payload length where we're working in strings and you have to make sure you convert it to bytes and then compute the length. We're working in bytes already, and you're just going to tell Python or JavaScript or Go, hey, decode this as UTF-8, and it just does that. You'd have to explicitly, and UTF-8's the default for like any language these days, the default encoding. You'd have to explicitly say decode this as ASCII only and don't allow UTF-8. It'd be extra work to not handle UTF-8. Yeah, I'm ready for spring break. I know that. All right, so here's our last thing we'll do before spring break. Let me copy this so I don't have to write it again. We don't need this anymore. And so that's up through Objective 3, the disconnects, the large message sizes. Objective 4 is persistent chat, storing things in the database, and when you restart the server, all your chat still shows up, which I actually don't have implemented. I just didn't refresh over here, which I do have to refresh, right? Yeah, because I need a new WebSocket connection. Chat should still work. And then we have these two buttons, Objective 5. I'm going to allow to use my camera. You'll get the close-up. Close-up, hey. I'm going to start my camera over here. I'm going to click Start Video Chat. And I'm, it's such a strange thing. And I have video chat between these two tabs, which could be two different users. Of course, they're using the same camera, so it's a little less interesting. But you should see a little bit of delay from the top one to the bottom one, because the bottom one's actually coming through the other browser, going through, not through the server, and establishing a peer-to-peer connection. It's being sent through that connection over to the other browser. So this is the WebRTC stuff. We're going to set up WebSockets and actually use WebSockets to negotiate a peer-to-peer connection between two users. They're going to send us WebSocket messages, and our server is effectively just going to forward those messages to the other client, and they'll be able to establish this peer-to-peer streaming connection using WebRTC. And that'll be Objective 5.
Can you leave it on?
For sure. And that's all I got. Anybody have questions? Triple Jesse. All right. Enjoy your break. I know I will. Get some rest. And I'll see you in a week.